Dear friends, good morning. As I have told you that I will be posting the problem that is based on the chapter number 1. So let's start with the problem number 1. Here is the problem number 1. Problem number 1 is that find the velocity or find the wavelength of the carbon dioxide molecule at a velocity of 440 meter per second. 440 meter per second. Now, what we have to find? We have to find the wavelength of the carbon dioxide molecule that is moving. Suppose this is carbon dioxide molecule, it is moving with the velocity of 440 meter per second. Now, remember that this 440 is given in the meter per second. Therefore, it is in the SI unit. Therefore, what we have to take? We have to take all the calculations in the SI unit. First, we know that how to calculate the wavelength. Wavelength we know that lambda is equal to h upon p, right? And p is what? P is the momentum, right? That we have learned. That is h upon p is equal to mass into velocity. So velocity is given. H is the Planck's constant, that is again in the SI unit, that is 6.626 into 10 raised to minus 10 raised to minus 34 joule second, right? If it is in the CGS unit, 6.626 into 10 raised to minus 27 erg second or second. The value is given in the SI unit, therefore we have to take this value in the SI unit, that is Planck constant value in the SI unit. So Planck's constant value we know that, velocity of the electron, velocity of the carbon dioxide we know that. Then we have to calculate the mass of the carbon dioxide molecule. Now CO2, carbon is having mass number 12, oxygen is having mass number how much? 16. 16 oxygen multiplied by 2, that comes out to be 16 into 2, that is 32 plus 12, that is equal to 44. So 44 is the mass number, AMU, that is in the atomic mass unit. So if you want to convert this atomic mass unit into the kilogram, because the mass, SI unit of the mass is kilogram. SI unit of the mass is kilogram. Remember that. So therefore, if you want to convert this AMU into the kilogram, we have to multiply it by 1.66 into 10 raised to minus 27. So therefore, this 44 into 1.66 into 10 raised to minus 27 kg. So if you want to convert this into the CGS unit, what do we have to multiply? Multiplied by 1.66 into 10 raised to minus 31 gram. Minus 30 gram, sorry. Minus 30 gram. So remember that. So the 44 multiplied by 1.66 into 10 raised to minus 27, that comes out to be 7.304 into 10 raised to minus 26 kg. That is the mass. Mass is value of mass is there. So in this equation, h upon mass into velocity. Velocity is already there. Therefore, lambda is equal to h upon p. That is equal to h upon mass into velocity. So h value 6.626 into 10 raised to minus 34 joule second. Then divided by mass, that we have calculated here, 7.304 into 10 raised to minus 27 kg multiplied by 440 meter per second. Now this joule and meter kilogram per second and joule will get cancelled. That is kilogram per second, that is equal to joule. Therefore, that is equal to per meter. That is equal to meter. The unit is get cancelled and only meter will be remain there. Therefore, that is equal to 2.06 into 10 raised to minus 11 meter. That is lambda is equal to, that is wavelength of the carbon dioxide molecule, that is equal to 2.06 into 10 raised to minus 11 meter, and this 2.06 into 10 raised to minus 11 meter, that can be converted into the centimeter or angstrom or nanometer, etc., etc. This can be converted. Now we know that 1 nanometer is equal to 10 raised to minus 9 meter, right? 1 angstrom is equal to 10 raised to minus 10 meter, right? Likewise that we can convert this value, that is 2.06 into 10 raised to the minus 11 meter, that comes out to be 0.2, that is lambda is equal to, that can be converted into the meter also, that can be converted into the Armstrong also. I want to take it as a in the Armstrong value. Therefore, if I divide by 10 raised to minus 10, that will be, let's see, that is 0.206 into 10 raised to minus 10 meter. Right, if I divide by this value, value I have converted into the 2.206 into 10 raised to minus 10 meter. One digit I have moved. Therefore, if I divide it by 10 raised to minus 10 meter, that comes out to be in the Armstrong value, that is lambda is equal to 0.206 Armstrong. Likewise that I can convert into the meter also. Simply divide 10 raised to minus 9, that will be converted into nanometer, not meter, nanometer. Now remember that here is the unit conversion that comes out to be in the meter, that is what is the unit conversion, that is joule second divided by kilogram into meter per second. Joule second, that is divided by kilogram meter per second. All the values will be get cancelled, only meter will be there. Unit conversion is not the part of this topic, therefore the value, lambda value will be in the meter unit, SI unit, that is in the meter unit. Remember that. Now let's go for, I hope you have understood this problem. Let's go for the problem number 2, that is problem number 2. Now this problem is new one, right? It is based on the photoelectric wave. Given that the work function for the sodium metal is 1.82 electron volt. Sodium metal, work function for the sodium metal is 1.82 electron volt. Calculate the threshold frequency nu0 for the sodium metal. Right, sodium metal. This is the sodium metal. Now we know that work function is given by psi. Phi is equal to 1.82 electron volt. Now this 1.82 electron volt value we can convert into the joule by simply multiplying the charge on the electron, that is 1.602 into 10 raised to minus 19 coulomb, that comes out to be in the joule, right? That is equal to 1.82 into 1.602 into 10 raised to minus 19 coulomb. Electron volt will be converted into the joule. That value comes out to be 2.9156 into 10 raised to minus 19 joule. That is 2.9156 into 10 raised to minus 19 joule. Now this electron volt value is converted into the joule, right? Therefore we know that phi is equal to h nu zero. Nu zero is what? Nu zero is threshold frequency. Therefore this equation psi is equal to h nu zero. Therefore nu zero is equal to psi upon h. H is the Planck's constant value. Again this joule, the value of the work function is in the joule. Joule is the SI unit. Therefore we have to take this Planck's constant value also in the SI unit. Therefore that 2.9156, this is 2.9156 into 10 raised to minus 19 joule divided by 6.626 into 10 raised to minus 34 joule second. Right? If I multiply and divide that comes out to be this joule and joule will get cancelled, that is equal to per second, that is per second, that is hertz, per second, that is equal to hertz frequency, right? So that comes out to be 4.40 into 10 raised to 14 per second, that is equal to 4.40 into 10 raised to 14 hertz, that is value of nu zero, that is value of threshold frequency. How it is calculated? If the work function is given, work function is converted into the joule, that is electron volt value converted into the joule. We know the Planck's constant, we know the SI value of the Planck's constant, we know the work function phi. From that we can easily calculate the nu zero value, right? I hope again you have understood this problem. So let's move for the next problem. Problem next, given that the work function for the chromium is 4.40 electron volt. So what is given? The phi is given, that is 4.40 electron volt, right? Calculate the kinetic energy of the electron emitted from the chromium surface that is irradiated with the ultraviolet radiation of wavelength 200 nanometer. Wavelength is given, lambda is equal to 200 nanometer. Now this is in the electron volt, this is in the nanometer. We know that. What do we know? That kinetic energy is equal to, that we have learned equation, kinetic energy of the ejected electron is equal to h nu minus phi. That is kinetic energy is equal to h nu minus h nu zero, right? This value is given in the electron volt. Therefore what we have to calculate? We have to calculate the kinetic energy of the ejected electron. What we have to calculate? We have to calculate the kinetic energy of the ejected electron. So kinetic energy is given by h nu minus phi. Phi is given, that is in the 4.40 electron volt. Therefore this h nu from this wavelength, how much wavelength? Wavelength is given, lambda is equal to 200 nanometer. 200 nanometer. Now, right now we have learned how to convert this nanometer into the meter or meter value into the nanometer value, because phi is in the electron volt, phi is in the electron volt. This h nu value we have to convert into the electron volt. So h nu is equal to what? H nu is equal to what? We know that nu is equal to C upon lambda. If I simply multiply h to this side and h to this side, right, that is equal to h nu value. So h nu is equal to h c upon lambda. Lambda is in the nanometer, right? Lambda is in the nanometer. To convert it into the meter, what we have to? We have to multiply it by 10 raised to minus 9. In the previous problem, we have divided by 10 raised to minus 10. That value was in the meter. That value we have converted into the Armstrong unit. But this is the nanometer value. Nanometer, that is equal to 10 raised to 1 nanometer is equal to 10 raised to minus 9 meter. Therefore, we have to multiply this lambda in the to convert into the SI unit into 10 raised to minus 9 meter. That is equal to, lambda is equal to 200 into 10 raised to minus 9 meter, right? So the h value, we know the Planck's constant value in the SI unit is equal to 6.626 into 10 raised to minus 34 joule second. Joule not per second, it is joule second, right? And c value, we know the velocity of the light in the SI unit, that is 3.0 into 10 raised to 8 meter per second. So 10 raised to 8 meter per second, this is in the SI unit, this is in the SI unit. This is also SI unit. Therefore, h nu is equal to 6.626 into 10 raised to minus 34 joule second into 3 into 10 raised to 8 meter per second divided by lambda value, that is 200 into 10 raised to minus 9 meter. 10 raised to minus 9 meter. This meter will get cancelled. This is per second and this second will get cancelled. The value comes out to be in the joule, that is equal to, that is h nu is equal to 9.93 into 10 raised to minus 19 joule. Now, in the previous problem we have seen that electron volt is converted into joule. How we have converted into electron volt multiplied by charge on the electron, 1.60 into 10 raised to minus 19 coulomb, right? 1.60 into 10 raised to minus 19 coulomb. So we have converted electron volt into the joule. In this case, the work function psi is given in the electron volt. Either way around we can convert. This psi can be converted into the joule, or this h nu that can be converted into the electron volt. The problem is kinetic energy is equal to h nu minus phi. Therefore, this h nu value, phi value is given in the electron volt. Therefore, kinetic energy is equal to h nu minus how much electron volt value? 4.40. Phi value is given 4.40 electron volt. This h nu can be converted into the electron volt, as I have told you. Simply divide by 1.60 into 10 raised to minus 19 coulomb, that will be converted into electron volt. That is h nu is equal to how much? 6.2 electron volt. If I divide this 9.93, this 10 raised to minus 19, 10 raised to minus 19 will get cancelled. 9.93 divided by 1.60, that comes out to be 6.2 electron volt. Therefore, kinetic energy is equal to 6.2 electron volt minus 4.40 electron volt, that is equal to 1.80 electron volt. Now, this electron volt value that can be converted again into the joule, that is equal to 1.80 into 1.60 into 10 raised to minus 19 coulomb, that will be equal to in the joule value. That will be equal to in the joule value, that is 1.80. Just calculate. 1.80 multiplied by 1.60, that is 2.80. That is equal to, this value is equal to, total value is equal to 2.88 into 10 raised to minus 19 joule. Therefore, kinetic energy of the ejected electron is equal to Ke is equal to 2.88 into 10 raised to minus 19 joule. Simply we can make the calculation, right? This is all about the problems. Remember that the problem may be asked anything. Values may be converted in the anything. What we have seen the three different problems. We have calculated the wavelength of the carbon dioxide molecule. In other case, they may change the, instead of carbon dioxide molecule, they may take the tennis ball and mass will be given, right? Mass will be given, suppose 500 gram. So this gram is converted into the kilogram, SI unit. Again we can easily calculate the value of lambda, right? H value we know that in the SI unit, P mass into velocity. Mass they are given 500 gram, that is equal to 0.5 kg, right? 0.5 kg, and velocity will be given. Velocity we know that in the cricket ball 150 meter per second, right? That is velocity will be given, and we can easily calculate the wavelength of the moving tennis ball. Or in some time they will give the mass, they will give the lambda value, wavelength value. They may ask to calculate the velocity of the electron, right? In this problem, work function is given, nu zero they have set to calculate. Some problem they may say in the other way around, nu zero will be given, they may say that the work function calculate. We know that nu zero, if the nu zero is given, Planck's constant is known, then we can calculate the work function. Right, we can easily calculate the work function. In other problem, kinetic energy is equal to 1 half mu square. Right, kinetic energy of the ejected electron is equal to h nu minus psi. They may give the threshold frequency and work function. They may give this one h nu value. They may ask to calculate the kinetic energy. They may give the kinetic energy. They may give this radiation wavelength. Then they may ask to calculate the phi value. That is the work function value. So other way around problem can be asked in the exam. Please remember that. This is all about the problems that is in the chapter number 1. In the last lecture we have seen the wave number to calculate, how the wave number is calculated, and the strongest and smallest line that can be calculated in the Balmer series and in other series. We have to remember very standard formula, nu bar is equal to R into 1 upon n1 square minus 1 upon n2 square, centimeter inverse, right? Centimeter inverse. Likewise that they may ask the problems. So please remember that. Don't forget this formula. Okay. So this is all about the problems of the chapter number 1. Thank you.